Hey there, Thomas. Okay, so I'm looking at number 1 here on the final exam review. Part B. It looks like we've got this function p equals 4t squared times e to the t plus 1. Okay. I would say this is basically a product rule because we have this function over here, 4t squared, and we know how to take the derivative of that. And we have this function here, e to the t plus 1, and we know, or we should know, how to take the derivative of that. So if you have two functions that are being multiplied and you know how to derive both of them separately, then the product rule should apply. So I'm going to call this piece A here, and I'm going to call this piece B. Okay, so the product rule would be the total derivative is going to be the derivative of A times B plus the derivative of B times A. So we're just going to go over here and figure out A prime. Well, if A is 4t squared, then A prime should be 8t. And if B is e to the t plus 1, this is technically a chain rule because e is being raised to the power of t plus 1, which itself is a function. So B prime is going to be the original e to the t plus 1 times the derivative of t plus 1, which actually in this case is just 1. So kind of an unnecessary step, but I just wanted to remind you that e to a power can be considered a chain rule. So look out for that on your test. I guess a side note would be if this was like e to the t squared, then its derivative would be e to the t squared times, what's the derivative of t squared? 2t. So that's where the chain rule would come in for an e power. But like I said, in the example that we're doing now, the derivative of the e power is just 1. So we don't really need it. Okay, so then we're just going to plug everything in. A prime times b is going to be 8t times e to the t plus 1 plus b prime times a. So that's just 4t squared times e to the t plus 1. And this right here is your derivative. I think you can leave it like that. You could simplify it. So if you need to simplify it, and I'm noticing both terms have a 4t and an e to the t plus 1 in them. So if you factor that out, I think the first piece is just going to be 2 plus, second piece is just going to be t, because you factor out a 4, a t, and an e to the t plus 1. So this would be an alternate form, slightly simpler. So depending on how picky your teacher is, you may need to simplify it. Okay, so let's take a look at part G. I'm going to clear this. Okay, so part G, they give us the function y equals 1/3 of ln x cubed plus 1. So we're going to remember that this is a chain rule, right? The ln piece has a derivative. and the inside of the ln also has a derivative. So we need to figure out what is the derivative of ln and what is the derivative of x cubed plus 1. So the derivative of ln is always 1 divided by whatever's being logged. So we're going to get 1/3 constant multiple times 1 over the inside. Okay, so that's the derivative of the ln part. And then, because there's a function inside of that, we need to figure out what is the derivative of x cubed plus 1. And that happens to be 3x squared. Okay, and then you could probably combine all this. Oh, the 3 and the 1/3 undo each other. And so I think what you're left with is x squared over x cubed plus 1. And I think that's it. You can't really simplify this one any further, so that's going to be the final answer. Okay, I'm going to go ahead and clear this. Okay, so now we're looking at 2c. So 2c is an integral, and we need to integrate, in this case, 2p squared over p cubed plus 1 with respect to the derivative of p. So I think this is going to be a u-substitution, and the reason that I think that is because I'm noticing the piece on the bottom, if you make that u, so if you make u p cubed plus 1, then the derivative of u with respect to p is going to be 3p squared. Oh, that's not what we usually write, is it? We write du equals 3p squared times the derivative of p. Now 3p squared is pretty close to 2p squared, so I think we can rectify that with a constant multiple. So what I'm going to do is divide everything over here by 3 and 3, so we get 1/3 of du is equivalent to p squared times dp. And this p squared times dp, this already exists in the integral right here. So this piece is going to be crossed out, and it's going to be called 1/3 of du instead. So we've got 2 divided by u times 1/3 of du. Now, like I think we talked about this last time, anytime you have some constant multiples, so we have a 2 and we have a 1/3, we can just factor those out, put them on the outside of the integral, make it even easier. So we've got 2 times 1/3, that's actually 2/3, integral 1 over u times du. And if you have to integrate 1 over u, this is a special case, but it happens to be equal to the natural log. So what we have is 2/3 of the natural log of u. Actually, it has to be absolute value. Well, this is going to be u plus some constant. And then, because our original question did not have a u in it, we're just going to resubstitute p cubed plus 1. So we've got 2/3 natural log p cubed plus 1 plus some constant. And that's going to be the answer. The reason I'm including the absolute value, well, anytime you integrate 1 over u, the answer is going to be natural log of absolute value of u. And the reason is because you can't natural log negative numbers. So you just have to use an absolute value. Okay, so the next one I have is number 5. And we have a travel agency will plan a group tour for groups of 25 or larger. If the group contains exactly 25 people, the cost is $275 per person, and each person's cost is reduced by $5 for each additional person above 25. Construct a table that gives the revenue generated for 25, 26, and 27 people. It's kind of interesting. Okay, so we need a table. We have like number of people. Based on the number of people, we can figure out how much each person has to pay. So charge per person. And then obviously if you multiply those two numbers, you would get the total revenue. Okay, so we've got 25 people. They told us it's definitely going to be $275 per person if there's 25 people. And then if there's 26, the cost per person decreases by $5. So we got $270. And then if there's 27 people, we've got $265. Now we can quickly multiply these. Okay, so here's our completed table. As you can see, as you add more people, the travel agency still makes more money even though they're charging less per person. So, I mean, that's probably what you want if you're in business, right? Get a better deal for everyone. Okay, so part B says find the revenue function. Use X for the number of people above 25. Okay, so the revenue is going to be it's basically the number of people multiplied by the dollars per person. It's the multiplication of the first two columns. And we're defining X as the number of people above 25 people. So that means if there's exactly 25 people, the value of X is going to be 0. So if we're going to be calculating, well, let me add a little. Our X values that correspond to this would be 0, 1, and 2. So really, if we want to put our revenue in terms of X, it's going to be the number of people is actually going to be X plus 25, right? And the dollars per person is going to be $275, so that's the starting cost, minus 5X, right? Because it's minus $5 for each person above 25 people. So this should tell us our revenue. We need to, do we? We probably need to FOIL this out because we're about to find its derivative anyways. So 275x minus 5x squared minus 125x plus 25 times 275, which is 6875. Okay, so we get negative 5x squared plus 150x plus $68.75. And this is going to be our revenue function in terms of x. So here you go for part B. Here's our revenue function. Okay. Then we need to find the marginal revenue function. So that's basically the derivative of the revenue function. And that's going to be negative 10x plus 150. That tells us for each person that we're adding, how much does the revenue increase, right? Because a derivative is a rate of change, and this one is the rate of change in revenue with respect to the number of people. So it's like if you increase the number of people, what happens to the revenue? Then we want to find the x value. Oh, sorry, this is part B. This is part C. Then we want to find the x value that maximizes the revenue. Now, I think I mentioned this last time. Anytime you're asked to find a maximum or a minimum, you're going to take the derivative function and you're going to set it equal to 0. So let me erase some of this. I'm going to leave our functions because we probably still need them. But I am going to erase the table. Hopefully we don't need that. Okay. So for part D, find the x value, which is really the number of customers, for which the revenue would be maximized. So we're going to take our derivative and we're going to make it 0. So we get 0 equals negative 10x plus 150. You subtract 150, you divide by 10, you find out x should be 15. Find the maximum revenue. Okay, so now we found out the number of customers that would maximize the revenue, and we have a revenue function. So what we're going to do is we're going to take r of 15. So that's just negative 5 times 15 squared plus 150 times 15 plus 68.75. Okay, so the revenue, when we have 15 additional people, should be $8,000. Okay, so there's, is that part E? That was part E, that's the maximum revenue. Okay, so now, well, yeah, that's the end. The next one is number 7. Okay, so I'm going to clear this out. Number 7. Number 7 says, a restaurant has an annual demand for 2,000 bottles of a particular wine. It costs $2 to store 1 bottle for 1 year. It costs $20 to place an order, and wholesale price to the restaurant is $10 a bottle. Assume the demand is constant throughout the year. A, what is the cost associated with buying, ordering, and storing all 2,000 bottles at the beginning of the year? So it looks like we have 3 things that increase our cost. We have to buy it. We have to order it. And we have to store it. Now, I think we've done a problem like this before, perhaps, where if you're storing 2,000 bottles at the beginning of the year, obviously your goal would be to sell them by the end of the year. So on average, you're storing 1,000 bottles. So what we're going to do is make our storage calculation for 1,000 bottles. It costs $20 to make an order, $10 per bottle. Oh yeah, so okay, so if you buy all of them at once, your cost is going to be $10 per bottle times 2,000 bottles, plus I think it costs $20 to place the order, plus a storage cost of $2 a bottle, times, on average, we're going to have 1,000 bottles in storage. So this is 20,000 plus 20 plus 2,000. So that's $22,020. So that's going to be part A. No calculus yet, right? Just kind of some logic, a little bit of algebra. Okay, part B says, what would the total cost be to the restaurant if it placed 2 equally spaced orders throughout the year? Note that each order would be for 1,000 bottles. So perhaps our storage cost goes down, but we are paying an extra fee to make the order. So let's see what's going on here. Let me erase some of this. Erase the graph. Okay, we have a new graph, right? By the end of 1 year, we bought 1,000 bottles. We depleted that. We purchased another 1,000, and hopefully by the end of the year we sold that too. So then this time, on average, we're only storing 500 bottles at a time. So our storage cost is going to go down significantly, but we're paying that extra 20 bucks to place 2 orders. So hopefully it'll cancel out. Okay, so we're still buying 2,000 bottles of wine. So that's a fixed cost basically. We're placing 2 orders, so that's 40 bucks, and then we're storing on average 500 bottles for $2 a bottle. So we've got still, right, the 20,000 for the wine, that's not changing. 40 bucks to place the orders, and $1,000 for storage. So we still came out ahead, right? We got $21,040 is our total cost now. And let's see. That's going to be part B. Part C is, what would be the total cost function if the restaurant placed n equally spaced orders throughout the year? Okay, that's interesting. Now we're going to have to do a little more serious algebra here. Still no calculus, right? Okay, so, well, let's see. The cost of the wine itself is still a fixed cost, right? We need 2,000 bottles, and we're paying $10 a bottle no matter what. To place the order, that's $20 each time we place an order, and we're placing in number of orders, so 20 in. And then to store it, we are paying $2 a bottle to store for 1 year. Okay, so we're going to have to do some math on this one, right? The storage cost is $2 times the number of bottles that you're storing at any given time. And the number of bottles that you're storing at any given time is half the amount of your purchases. And each time you make a purchase, you're going to have to purchase 2,000 divided by n bottles, right? Because you still need those 2,000 bottles, but we're dividing it up to n number of purchases. Anyways, I think the two and the 1/2 cancel out. So you just get 2,000 over n. And so now our total cost function actually is a function. It's 20,000 plus 20n plus 2,000 divided by n. And I believe my logic is good there. So that's going to be part C. I don't know why I have a B here. It should be part C. Okay, part D says, what is the number of orders per year that should be placed in order to minimize the total cost? So again, the key word here is minimize. So that tells me that we should find the derivative of our cost function, set the derivative equal to 0, and that would tell us the point at which our cost will be minimized. So that's what we're going to do for part D. We're going to find the derivative, which this piece goes to 0, this is 20, and this should be this 2,000 over n, this could be written as 2,000 n to the negative 1. So its derivative is going to be negative 2,000 n to the negative 2, or negative 2,000 divided by n squared. Okay, so here's our derivative, and now we're going to set it equal to 0. So 0 equals 20 minus 2,000 over n squared. We add the 2,000 over n squared to both sides. Actually, I'm going to erase a little bit here. Okay, so we're going to move back up to the top here. So we get 0 equals 20 minus 2,000 over n squared, which turns into 2,000 over n squared equals 20. We can multiply both sides by n squared. We get 2,000 equals 20 n squared. We divide by 20. I think that's 100 equals n squared, which means n should be 10. Okay, so that means if we place 10 orders throughout the year, that's going to be like best case scenario. That's going to reduce our storage costs without raising the cost of making all these different purchases by too much. Okay, and then part E says, what is the minimum annual cost? So now that we know how many orders we should place, we're just going to plug this back in here to our cost function and find out. So that's going to be part E. So part E is we're trying to find the cost of 10, C of 10. So that's 20,000 plus 20 times 10 plus 2,000 over 10. So that's the 20,000 plus 200 plus 200. So that's 20,400 is the smallest possible cost. And remember, the 20,000 is just to buy the bottles of wine, so we're basically talking about $400 of overhead here, which it seems like a minimum to me, so it seems reasonable. Okay, I'm going to clear this out. Okay, so the next one I have here is number 10. And we have something here that we actually, well, at least you and I have not talked about. So this is a differential equation. There's a whole class over this, but this is a real simple one. So basically, instead of giving us a function, they give us the derivative of a function. And it's a little weird because the derivative of p with respect to time is negative 0.1 p. So the derivative of p involves p. So when the derivative of p involves p, we're talking about exponential decay and or growth here. So the first thing that we need to do to solve an equation like this is get all the p's on one side and get the t's on the other side. So basically we're going to multiply both sides by dt, so you get dp equals negative 0.1 p times dt. And then you just divide by p, so you get dp over p is equal to negative 0.1 dt. Okay, now this could actually be written as 1 over p times dp. Okay, so now that we have it set up like this, basically you integrate both sides. The integral of 1 over p, I mentioned this earlier, this is going to be the natural log of p, actually absolute valued, and then this is going to be just negative 0.1 t. Okay, I'm going to go back up to the top. So we have ln of p is equal to negative 0.1 t. Now this is actually a log base e of p equals negative 0.1 t. Ooh, you know what? I forgot the constant. There should be a constant on one side or the other. You don't really need two constants, even though we did two integrals. So I'm just going to add it over here. So I'm going to say this is like plus some constant. So this is plus some constant. Okay, so now what we're going to do is we're going to turn our log into an exponent. So log base e of p is equal to something really means e to that power, so negative 0.1 t plus a constant is equal to p. We can separate this left side because of the rules of exponents. We're going to call this e to negative 0.1 t times e to the constant is equal to p. And then we're going to use the initial value that they told us. So they told us when basically when t is 0 that p is 100,000. So we're going to get e to the negative 0.1 times 0 times e to the constant is equal to 100,000. And actually, if you think about it, e to the power of a constant is just some other constant. So this is actually going to be replaced. Well, it's not replaced, but this is kind of like our initial value. So this is what we're solving for. So I'm going to replace that with just calling that a constant. So e to the negative 0.1 times 0 times some other constant is equal to 100,000. Now e to the power of 0 is actually 1. So we find out that our initial value, is just 100,000, which makes sense in an exponential decay problem like this. So we're going to go back up to, well, I'm going to erase the left column here. So basically we have P is equal to A, right, some constant times e to the negative 0.1 t. And we found out that our initial value, our A, has to be 100,000. So we find out P equals 100,000 times e to the negative 0.1 t. And differential equations like this pretty much always work out the same because you can tell it's exponential decay. And you know the rate of decay is the negative 0.1, so that's here. And they told you the initial value should be 100,000, so that's there. It's almost always going to take this format. So this is called the particular solution to the differential equation. This is part A. What happens to the purchasing power as the years go by? Well, it decreases, right? If you plug in higher and higher values of t here, 1, 2, 3, 4, what's going to happen is your purchasing power is going to go from the initial value of 100,000, 100K, and it's going to slope downward like this. So I think basically this means due to the inflation, your $100,000 a year in 1 year is not really worth 100,000. It's worth more like 90,000 or something, right? And then the year after that, it's worth it's 10% less than that. So you could also graph this on a calculator, and hopefully it looks something like this. It should be an exponential decay function, and the initial value on the y-axis should be 100,000, right? Because at year 0, your $100,000 would be worth $100,000. Okay, and then find the purchasing power after 5 years. You just plug in t equals 5. So you're going to get, part C is going to be the 100,000 times e to the negative 0.1 times 5, so that's negative 0.5. Okay, so we're looking at 60,653. So if you're looking at a 10% inflation rate, which is really high, your $100,000 would be worth something more like 60,600 in 5 years. So this is bad, right? You want your inflation to be low enough so that people invest their money, right? If you put $100,000 in a savings account, 5 years later it's only worth 60K, you're gonna do something else with your money. So if the inflation rate is too high, people don't save money, and people don't think about the future because their money would be worthless. What's the point of thinking about the future if there's no point? Okay, so the next one I have is number 12. I'm going to clear this out. Looks like this might be the last one. Okay, so a printing firm considers its productions as a continuous income stream. If the annual rate of flow at time t is given by 99.5 times e to the negative 0.2 t plus 3 in thousands of dollars per year, sketch the graph of ft. Shade the region that represents the total income over the first 5 years. Okay, so you want to pull up your graphing utility, and you want to go to your y1, and you want to set it equal to 99.5 times e to the negative 0.2 times parentheses x plus 3. Again, because we have an e to the negative power, we're basically talking about an exponential decay function here. So I'm not sure what the starting value is in this case, but our graph should look something like this. And then don't forget, each point on this curve is like how much money is coming in within a specific unit of time. So the total income is going to be the area under the curve. So the income in the first 5 years is going to be this area here. Okay, so that's part B. Shade the region that represents total income over the first 5 years. What will be the total income from this income stream over the first 5 years? So now they're actually asking you to find the area. And the area is going to be calculated using an integral. Right, this is a weird shaped piece, so we're going to have to integrate it to find the area. So the area under the curve should just be 0, 5 of this whole thing. Times the dx. Okay. We have a constant of 99.5. We can factor that out already. So we've got a 99.5. Integral 0, 5 e, and then I'm going to distribute that negative 0.2. So we've got an e to the negative 0.2x plus, minus 0.6. Okay, so that might make it a little easier. Now, we know how to integrate e to the x. We do not know how to integrate e to the negative 0.2x minus 0.6. So that's a good hint that we should use u-substitution. So we're going to make u equal to negative 0.2x minus 0.6. du is going to become negative 0.2 times dx. If we divide by negative 0.2 on both sides, we find out that the dx could be represented by negative 5 du, I believe. Dividing by negative 0.2 is the same thing as multiplying by negative 5. Okay, so then we're going to rewrite this one more time. We got 99.5, 0, 5. Now it's just e to the u times negative 5 du. Okay, again, this negative 5, that's going to come to the outside, so negative 5 times 99.5. So we bring all of our constants out, if you can. So negative 5 times 99.5 is 497.5. So we got negative 497.5 integral e to the u times du. Now we did all that work because the integral of e to the u is just e to the u. Okay, so we can evaluate the integral. Negative 497.5 times e to the u, which is actually e to the negative 0.2x minus 0.6. Right? You plug u back in, or you plug your x's back in instead of u. So we got negative 497.5 e to the u. And then we have to evaluate this at 0. We have to evaluate this at 5. And then we're going to subtract the difference. I said that backwards. We're going to evaluate it at 5 and at 0. And then subtract those. So you do the 5 first. So you get negative 497.5 times e to the, that's going to be negative 1 minus 0.6. Getting a negative number. So negative 100.44. And that's going to be minus, what happens if we plug in 0? So negative 497.5 times e to the negative 0 minus 0.6. So that's really just e to the negative 0.6, because that other piece is 0. For this one, you get negative 273.03. Now when you subtract the two, you should get a positive 172.59. If I'm not mistaken, that's in thousands of dollars. That is in thousands of dollars. So our total income over those 5 years must have been $172,590 approximately. Actually, I rounded off. Maybe you could use more decimals and get a more specific answer. Suppose that the money is worth 6% compounded continuously. What is the present value of the income stream over the next 5 years? And then what is the future value of the income stream over the next 5 years? I think we're just going to use this 172,590, and we need the present value and the future value equations. Okay, so I actually paused the video recording and was doing a little research on present value and future value to try and figure out exactly what they're talking about here. And I don't know. So actually, I think the answer to part D is the same. I think it's 172,590. I could be wrong. But the present value over the next 5 years, according to Wikipedia, the present value is just how much it would be worth right now. I'm still thinking. I don't know. I got nothing, man. You may want to like shoot an email over to your professor and ask him how to approach that. The reason is you're not getting all of the money now. This is an income stream and you're getting it over the next 5 years, but at an ever decreasing rate. Like according to this chart, right? You're gonna get more money the first year than you would the second year, and you'd get more the second year than you would the third year because the amount of money you're getting each year is decreasing. So to calculate how much money your income stream would be worth in the future would mean, I don't know, the only thing I can think of is that you would have to integrate the integral, in other words, and that's like a double integral, and that doesn't make any sense. So anyways, I would recommend just checking with your professor and asking him, and if you find out something useful, let me know, because I'm not really sure what to do here. Anyways, this is the last one, so I'm going to go ahead and stop the video, and if you need any further questions answered, let me know, and good luck on your exam.